we present our interactive missing completion system. It uses mouse clicks and scribbles to interactively complement missing 3D point cloud data from a room scan. Using this system, we get the 3D model of the room with the scanned furniture removed. There are two types of missing parts, shape and texture, so we complement each of them. First, we introduce the shape completion system. This is the interface of the shape completion system. After entering the 3D point cloud data into the system, we press the button that provides the missing completion function, which opens a window displaying the 3D point cloud data. A corner of the room is missing and we complement it. Select 3 points on the plane that we want to complement. Then the point clouds are created in the same plane and covers the missing points. This operation is performed on all missing surfaces. It's hard to see the whole room in this state, so we use the function to make the corners of the room stand out. We can choose the corners of all the rooms that are missing because there are point clouds that complement the corners of the rooms that are missing. Selecting all corners of the room turns only the corners red and the rest of the room blue. Next, select the information for the corners and normal vectors of the planes to be reconstructed, per one plane. Finally, the plane is created as a mesh. The instructions appear in a window in the upper right corner of the screen, making it easy for even beginners to use. Next, we introduce the texture completion system. This is the main window of the texture completion. When the user inputs a texture image to be completed into the system, the paint window opens. The user can scribble into this window and have it interactively complete the texture image. First, we erase the furniture from the bottom half of the texture image and complete it so that it becomes a wall. There are 3 colors to be filled: white, black and gray. We start by filling the texture image with white and selecting the pixels to fill the furniture area. Next, use black to fill in the area of the furniture to be erased. And then, the mask image is displayed in the center of the main window. This allows the user to see how the system perceives the selection of completion pixels by the fill. The completion algorithm runs automatically every 15 seconds after the black and white is painted. The result is displayed in the main window. When we focus on the textured image, we can see that there are white pixels in addition to the painted ones. In this case, using gray to fill in the white area is not related to the completion. When the user presses the button in the main window, the result of the completion is reflected in the paint window. If the result is wrong, the previous operation can be repeated to complement it as the user desires. Next, since the curtain is missing, we use the same operation to complete the curtains. The user selects the points to be complemented by the scribble so that the curved edges of the curtain can be completed. One of the advantages of this system is that the scribble allows for user-driven completion. This section discusses shape and texture composition. We use existing modeling tools. This time we use Blender. The 3D model of an empty room can be obtained by combining shape and texture images. The output 3D model has some distortions compared to the pre-completion 3D model. But, we get the 3D model of the empty room without any furniture. This is an application example. By getting an empty room, we can simulate the furniture arrangement of the room in virtual space. Furniture arrangement simulation is done using Dollhouse VR system. The 3D model of the room in this study is input into Dollhouse VR. The 3D model of the furniture is from Dollhouse VR. The user can also change the camera's viewpoint. It is not different from the furniture arrangement in the real space. This is because the 3D model reproduces not only shapes, but also textures.